All right, let's dive into a really important paper today. It's a game changer for anyone who works with text data in their research. Large language models, or LLMs, they promise to completely change how we work, but it turns out they come with some pretty serious hidden risks. So let's get into it. So if you're a researcher, you know this pain. You've got this mountain of text, right? It could be interviews, social media posts, product descriptions, whatever. And you have to sit there and manually read and categorize every single one. It's just so slow, it's super expensive, and it's a massive bottleneck to getting anything done. And then, suddenly, LLMs show up. And they promise this absolute dream scenario. Just feed them your text, and they'll do all that tedious classification work for you for a tiny fraction of the cost and in a fraction of the time. I mean, it sounds almost too good to be true, doesn't it? And that's really the catch here. It is true that these models can do the work, but, and this is a big but, if you just use them without thinking, you could end up with research that points to completely wrong conclusions. So what are these risks? And more importantly, how do you avoid them? Okay. So let's just quickly break down the options we've had until now. On the one hand, you've got traditional methods. Human coding is great for nuance, but you can't really scale it up. Supervised machine learning, that scales, but you have to pour a ton of time and money into creating this giant training data set first. But then, you look at the LLM approach. Fast, low cost, scalable, and you don't need to pre-train it. I mean, for a social scientist, that is an incredibly tempting proposition. So to make all this a bit more concrete, the authors of the paper applied this to a real-world question. They took a look at nearly 300,000 Kickstarter projects to answer something pretty simple. Do projects that talk about sustainability or social benefits actually get more funding? Okay, so what they did was test a whole bunch of different models and different prompting strategies on the same data. And the results for just simple classification accuracy, well, they were all over the place. The best combo, GPT-4o with a fancy tree of thought prompt, was an amazing 94% accurate. But look down at the bottom. Simpler prompts with less powerful models were barely better than flipping a coin, sinking as low as 41.6%. This is our first huge warning. Your choice of model and prompt matters a lot.
Now, here comes the bombshell. This is where it gets really wild. This chart shows the actual effect of sustainability claims on a project's success. That first bar, that's our ground truth from the human coders. It shows a strong positive effect. But look at that middle bar. That's from a model that was 87.6% accurate. It came to the exact opposite conclusion, that these claims actually hurt a project. And then, crazier still, a much less accurate model, at only 55.6%, it actually got the right answer, identifying the positive relationship. This is the absolute critical finding of the paper.
So you have to be asking, how is that even possible? How can a more accurate model get a worse result? Well, it happens if the model's errors aren't random. If the model has a bias, if it tends to make mistakes on, say, projects that are more likely to fail anyway, then even with high overall accuracy, your final results can be completely wrong. They can even point in the total opposite direction. Okay, so that sounds pretty scary, right? But the good news is, the paper doesn't just point out the problem, it gives us a solution. It lays out this clear 5-stage framework to guide researchers. It basically walks you through every single decision point from should I even use an LLM all the way to how do I make sure my results are solid. It's a roadmap to avoid these dangerous traps. Let's just zoom in on stage 3 for a second, prompting. This is all about how you actually ask the AI to do its work. And the main takeaway here is that there's no single magic bullet. A simple zero-shot prompt is fast, but it might not be that accurate. A few-shot prompt, where you give it examples, boosts accuracy, but you risk the model just kind of copying your examples. And chain of thought lets you see the AI's reasoning, but it costs more. The point is, every single choice you make has a trade-off. So if every choice we make creates this variation, what are we supposed to do? Well, the paper argues that we should just stop looking for that one perfect prompt or the one perfect model. Instead, we should embrace the variation by running what's called a sensitivity analysis. The goal isn't to find a single fragile number, but to really understand the range of possible outcomes. And the process itself is actually pretty straightforward. You just start by writing one clear, well-thought-out prompt for your task. You can think of this as your starting point, your baseline. But here's the key. You don't stop there. The core idea is to then systematically create and test dozens, or in this case, even hundreds of different prompts. You're trying different wording, different examples, different reasoning styles. Basically, you're stress testing your finding to see how stable it really is.
So after you run your analysis with all those different prompts, you get a distribution of results. And now, instead of just one fragile answer, you can report a really robust bounded estimate. A mean effect plus or minus a standard deviation. This tells you not just what the effect is, but how confident you can really be in that number, given all the uncertainty.
And honestly, this might be the best part. You might be thinking, this sounds like a ton of work, but the authors made it incredibly practical. They provide open source code in both Python and R, so with just a single function call, you can run this entire sensitivity analysis on your own data. It makes this super rigorous approach accessible to pretty much everyone. So let's just quickly recap the key takeaways here for your own research. First, if you ever see a study that uses an LLM with just one model and one prompt, be skeptical. Second, please remember that high accuracy on the classification task is not a silver bullet. It does not guarantee your final conclusions are correct. Third, our goal should be to report a robust range of findings. And finally, document everything: the model, the version, the date you accessed it, and every single prompt you used.
For any of you who want to dive in and actually use this methodology for your own work, the authors have made all the code and the documentation public. You can find it right at this link. It is a fantastic resource.
This quote from the paper really just says it all. The power of these amazing tools isn't really about having the newest, shiniest model. It's about how carefully and how thoughtfully we design our research to account for their weird, unique properties.
And that really leaves us with a final, kind of provocative thought. These tools are incredibly powerful, no doubt, but they also introduce this new level of instability and uncertainty into our work. So maybe the future of good science isn't about finding that one single perfect answer, but about honestly and rigorously mapping the boundaries of what we can actually know.